So I'm actually going to give an example of subnetting here in a little bit, but when we're analyzing subnets, these are some things we'll want to look for. First, what is the original classful network that we're talking about? To find this, you would simply look at the first octet. It's very easy. Second, we'll want to look at how many subnets are possible for the given subnet mask. And so remember, we're borrowing some additional bits in addition to the bits that were allocated for the network portion by the original classful network. We're now looking at borrowing more bits to be used as the network portion. And so based on that number of bits, how many possible subnets could we have? And then for that, we'll use look at the number of bits used for subnetting. So in CIDR notation, it would be that number after the slash, or in dotted decimal, you'll have to do the conversion. After we do that, we'll want to subtract the number of bits that we used for the network portion. So for example, if we have a class A address, that would only be 8 bits used for the network portion. And so we'll take from our subnet mask 8 bits. The remaining bits, the remaining n bits, are dedicated to subnetting, and based on those n bits, there will be 2 to the n subnets available, and there actually is an exception to that we'll talk a little bit about here in a second. The last thing you'll want to look at when you're analyzing subnets is how many possible hosts can be contained on each subnet. This is a very similar process. We're going to look at the number of bits in the subnet mask, and then we're going to subtract this number from 32 this time, instead of subtracting from that number the number of bits used for the network portion. So we're going to end up with 32 minus the number of subnet bits, and those last m bits, the remaining bits, are reserved for hosts. And in this case, we actually have to subtract 2, and the reason we do that is because of those special addresses we talked about. The network address, which is at .0, and the broadcast address, which is at .255. And so, just doing some initial analysis, let's go ahead and have a look at this particular example. And so we have the address 172.16.1.1 with a 255.255.255.0 network mask. So looking at this, I've went ahead and converted this to binary for you. And you can see that speaking in binary terms, the subnet portion of this address will end up being the logical AND, or the binary AND, of the first thing and the second thing, of the address itself and the subnet mask. And so if I AND the address with a subnet mask, it will give us 172.16.1.0. This would be considered the subnet. Now, real quick, just as a test to yourself, what is the CIDR notation for the subnet mask 255.255.255.0? What would the CIDR notation be? Just kind of note that to yourself. And you need to be very good at converting between these dot decimal notations, like that are displayed here, and CIDR notations, like what I showed you earlier, and be able to go back and forth between them. And so you can see here are some examples of this conversion, and you can see /8 would be considered a class A address, and in terms of a network mask, that would be written in dot decimal notation as 255.0.0.0. And you can see some examples here, and you'll notice that as we add more and more ones, as we borrow more bits for the network portion, we get these different numbers, these different sort of nice even numbers. So 128, 192, 224, 240, 248, 252, 254, and finally at the top 255. And you'll notice that pattern repeats from one octet to the next as we add more and more bits to the subnet mask. And so I would encourage you to be familiar with these subnet masks, and I would encourage you to memorize this pattern, this recurring numbers between 128 and 255, as you'll probably find those very handy when you're doing network masks that are not as nice as the ones that I've done in my examples here. For example, if you have a subnet mask 255.248.0.0, you're not going to have a chart to tell you that that's 13 bits. You're going to have to do the math yourself. And so, looking at this address, doing a little bit of further analysis on it, we can actually notice that the entire third octet is being borrowed for subnets. The reason I say this is if we look at the class of this address, the original classful network is going to be 172.16.0.0. And you'll notice that if we look at our network mask shows 3 octets are dedicated to the network. So in this case, we've actually borrowed the third octet to be used for this particular subnet. And in this case, we could actually have a number of different subnets. We could have 172.16.0.0/24. We could have 172.16.1.0, which is the network that we're actually talking about in this case. You could also assign 2.0, and so on, all the way up to 254.0, and finally 255.0. And so what I'm talking about here, these are not hosts that I'm talking about. These are possible subnets. Each of these is actually their own individual network that is basically a portion of that bigger 172.16 network. And so the 0 and broadcast subnet you'll see I have designated there, we'll actually talk about those here in a little bit. So to look at this address overall, just to give a final overview, this particular address and subnet mask pair, the network, the original classful network, is going to be 172.16.0.0. Again, that's going to be determined only by the first octet. If we're looking at the particular subnet, that's going to be determined by the subnet mask. And so looking at that, we actually see that we've borrowed 8 more bits. We've borrowed an octet. We've borrowed the third octet in this case. And that's going to be 8 more bits than we used in the original network. So that's going to give us 2 to the 8th subnets. And in this case, the particular subnet that we're talking about here is 172.16.1.0. And in this case, the number of hosts per subnet is also 8. Why? Because we have 8 bits left in the network mask. You'll notice that that 0 at the end is going to be 8 bits worth of zeros, and so 2 to that 8 bits of zeros minus 2 because of the network and broadcast portions will leave us with only 254 hosts in this network. So we're taking the bigger network, 172.16, and we're dividing it into 256 different smaller networks. In this case, this particular host resides on this 172.16.1.0/24 subnet, and that subnet could contain a total of 254 possible hosts. This one happens to be .1. And so this particular host happens to be .1. Now I'm going to talk to you guys about 0 and broadcast subnets. This is one of the pickier things in the networking world. So originally, when the standard first was released, there was an RFC that was released that prohibited the use and configuration of the 0 and broadcast subnet. What do I mean by that? That is the subnet where the borrowed bits, the subnet bits, are all set to 0 or all set to 1. I'm not referring to the host bits here. I'm referring to the borrowed bits. And you should go back and look at the previous slide if you're not sure what I mean by that. I actually did a quick example of what the 0 and broadcast subnets were. Now, these subnets can actually cause problems with classful systems, so I discourage their use, but in fact, by default, Cisco iOS devices will allow you to use and configure these special subnets. The IP subnet 0 command is applied by default. This is not something you actually have to type in. This is something that modern routers will automatically apply. You won't even see it in the configuration just because it's automatically there. And so subnet calculations can actually be performed in one of 2 ways. If you are borrowing n bits, you can do the traditional calculations where you remove the 0 in broadcast subnets, which will give you 2 to the n minus 2 subnets. Now you'll notice that's not the calculation that I told you guys to do. I told you guys just to do 2 to the n subnets. Now why is this? The IP subnet 0 command allows you to use the 0 and broadcast subnets in your network. And so these subnets are freely available to you. There's no restriction on whether or not you need to use these. So in all of your calculations, you should naturally assume, unless you were told otherwise, that all subnets are available to use and that the 0 and broadcast subnets are unrestricted. Again, do not use the traditional method unless you are explicitly told that either the IP subnet 0 command has been removed with no IP subnet 0, or if you're told that the 0 and broadcast subnets are unavailable to you. That just about wraps it up for this first presentation with respect to subnetting. I've actually got another subnetting presentation in the next module, but we're going to move on to a different topic in the next one. So again, leave comments if you have questions for me, and I hope to see you in the next presentation.